Welcome back to Code Snippets. Today we're going over scoping because that's such a huge and fundamental part of programming as a whole. And this is a big portion where a lot of people struggle. So let's get into it. So going back to declaring and initializing variables. In order to use a variable, we need to declare it. We need to tell Java this variable exists. So if we say something like a equals 4, Java doesn't know what to do, right? Because a doesn't exist yet. We haven't declared it. So if we say int a equals 4, now it knows what we're talking about, right? First, we have to tell Java, hey, this variable exists, and I'm going to reference it by using this name, whatever name you give that variable. And also going back to our timeline of code again, each line runs sequentially. So if we were to try and say a equals 2 up here, again, it wouldn't work because a doesn't exist yet, right? A only exists once we declare it and until it reaches this closing curly bracket right here. So if we move this line from here to here, now this works just fine because a exists from here to here, right? So this area where a exists from line 7 to line 9, we would call this a's scope. So it's just the region or block of code that a certain variable exists in. So the biggest thing to remember with scope are the curly brackets. So since a is declared within this set of curly brackets, it can only exist within this set of curly brackets. So an easy way to kind of remember this is what happens in Vegas stays in Vegas. So if a is declared within these curly brackets, it's going to stay within those curly brackets. For example, I'm just going to create an arbitrary set of curly brackets, like that. And I'm going to say int a equals 10. And now this works just fine. Then I can go right on the next line and print out a. So if we run this, we should see the number 10, and we do. So that's good, it works. Now what happens if we take this and move it outside of the curly brackets? Well, now we're getting an error because it's saying that a cannot be resolved to a variable, which makes sense because a was declared inside these curly brackets. So a only exists within that scope. So as soon as we exit these curly brackets, as soon as we leave Vegas, a no longer exists. So we need to, if we want to reference a again here, we would need to declare it again. So now a exists within these curly brackets on these two lines, or a line and a half, and then it disappears. And then we create a new variable which happens to have the same name. So these are actually two different a's that we're looking at. So this one only exists on these two lines, and this a exists on these 4 lines. So when we say system.out.println a, this should say 12, and it does, because it's referencing this a right here. Now, if we were to move this line here, right, what happens? Well, now we're getting an error. Why? Because we have a duplicate local variable. Because this variable a exists from this line until we reach the end of the scope that we're in, or the end of this code block. And that happens to be down here. So in this blue area, that's where this variable a exists. So we're trying to create a second a variable within that blue portion. So even though we've entered a new set of curly brackets, this set of curly brackets is actually inside this set of curly brackets. So this is sort of like a casino inside of Vegas, if you want to think of it that way, right? This casino is inside Vegas, so anything inside the casino is also by proxy inside Vegas. So this A already exists, right? This town's not big enough for two A variables. So if we take away this int, we're no longer declaring A as a variable. Now we're just changing its value, right? We initialize it as 12, then we change its value to 10, and if we print it, what happens? The value is 10, because this A variable is now referencing this one that we already created. We're not creating a new variable anymore. So let's relate this to methods. If we have a method called do something, and let's say we have a variable int a equals 10. Now, if I try to say sysout a, again, this doesn't work, because if we look for the scope of a right here, it stops existing once we get to this point right here. So a doesn't exist over here inside this scope. This has its own scope that's completely separate from this one, right? Where we had before, when we had the curly brackets inside of curly brackets, right? This code block exists inside this code block, right? They overlap. However, with this new method we've created, this method does not overlap with this one at all. It runs parallel, similar to that graph I created in the last two videos, right? They're parallel lines of code. They will never intersect, but we have to tell them, or, tell the main method, hey, I want you to run the do something method, right? So now this code will run, but it still has a different scope, right? We haven't changed the scope just because we called the method. So if we did want to print this variable a, well, first we'd have to declare a. We'd have to make it exist. So we'd have to say int a equals something. So let's just say 4, right? So we have an int a equals 10, and we run do something. Int a equals 4, sysout a. And if we run this, you could probably guess it's going to print out the number 4. So let's change this from int a equals 4. Let's remove that, and let's make it a parameter of our method. And now that means we need to pass in a number here. So let's pass in a. So you might be inclined to think that because we're passing in a, and it's going here, and they're both named the same thing, that they're the same variable. And although they might have the same value, they are not the same variable. Again, that goes back to scope. So this is something very specific. You don't have to remember this, but this is called pass by value. So all we're doing is when we call do something at a, we're saying, okay, instead of passing the variable a, just retrieve its value. So a is 10. So we're actually, essentially what we're doing is that. We're just saying do something and passing in the number 10. But we want to avoid hard coding, so we create a variable called a, and we set it equal to 10. In that case, if we want to change the 10 variable, let's say we're calling do something multiple times and we're passing in a every single time, we only have to change the one variable instead of saying do something 10, do something 10, do something 10. And then if you want to change that number, you have to change it for all of them. So we're just going to pass in a, and that's getting sent here. So we have this parameter here, and we pass in a number. Let's change this back to 10 just for the sake of example. And actually, we can comment this out to prove that this a and this a are two different variables, because once we've commented this line out, it doesn't affect this method at all. So it takes this value here, this 10, and it assigns it to this int a. So essentially what's happening is we're saying int a equals 10, because this is the value that we're receiving from right here. So that's what this part is doing. When we combine this int a, so that's this portion, and then equals 10, That's this portion. So now if we print this, we get 10. I also want to mention, because I don't think I mentioned it in the previous methods video, the name of this variable and the name of a variable that you pass in here. So let's bring this back. And we said do something A. The name of this variable and the name of this variable do not have to match. They do not, because they are not the same variable. So for example, I could name this whatever I want, and I'm going to do Alt-Shift-R. That stands for Refactor. And that allows you to change the name of a variable without going through and changing the names of every single time you wrote that variable. So for example, if I want to change it to the letter B instead, I can hit B and then hit enter. And now it changed it here and right here. So that's just a little something you can do in Eclipse. Again, to further emphasize this point that they're two different variables, when I refactored this variable called B, it didn't affect this variable down here. And furthermore, when I highlight this B, it highlights this as well, again, because there's the same variable, but A is not highlighted. And if we change that back to A, the same thing happens. These two are highlighted, but these two are not. And that boils down to a difference of scope. So this is something called local scope. When this variable exists only within these brackets, that's a local scope. And this method has its own scope that's different from this method up here, this main method, right? Because the main method is, in fact, a method. It follows that same format. So this has its own scope. This has its own scope. And as a matter of fact, because we have these brackets here, the brackets are your tell-all. That's how you determine scope. So because we have brackets here, this also actually has its own scope. So for example, if I said static int a equals 12. Let's do that. So now you might be wondering, well, hey, we declared a variable called a in this scope, and these two scopes are inside of this giant scope, right? And that is correct. So then, why aren't we getting an error right here? Well, because this is a local scope, but this is what's called a global scope. So they're actually two different things. And what essentially we're doing here is we're overriding what scope we're looking at. So if we remove the word int here, you'll notice this A became italicized and it changed color from yellow to that light blue. So now it matches this variable right here, this static int A. So this is our global scope coming into effect. As soon as we declare a local variable, int A equals 12, then we print it out again, A, and I'm going to comment this out for a second. If we print out A here, we're going to get two different A's. So if you notice, this A right here is light blue, this A right here is yellow. This one's italicized, this one's not. And if we print them out, you might be able to guess, this will print out 10, and this will print out 12. Let's run it. There we go. If we go down here, you'll see that int A right here is a dark blue. So this is our method scope. So it's dark blue, and if we look at this, this is also dark blue. So if we call do something, let's bring that back, and let's pass in the number 14. Keep the pattern going. Oops. If we run it, it prints 14. It does not print 12 or 10, right? Because this A is referring to this A, this variable right here. It's not referring to the global one. So if you have a more local scope, it will override it. So these local scopes and these method scopes override the global scope. So if we uncomment that, again, we're passing in this global A into our do something method, and that assigns it here to this method scope. So they're still different variables, but now they're referencing the same value. If we run it, we should see 10 twice, and we do. So that's what's happening there. So the main point of all of this, the main takeaway, is that if you want to reference a variable, it needs to be within your scope. So let's go back to the basics. Let's remove all of this extraneous data. And the biggest error that I see is, let's say we have a for loop. Just a basic one, it doesn't matter. And let's say we wanted to sum the data in an array. So let's create an array. And I'm just going to assign some random values in here. Just like that. If you don't know what an array is or how to create one, I do have a video on that. So you can go back through and watch that. And also, if you don't know what a loop is, I have a video on that as well. So we're going to say int I equals 0, where I is less than array.length, I++. And if we want to add all these numbers together, you might think, okay, well, we're going to need a variable called sum, or something similar to that, and we're going to add all the values to it. So let's create int sum, and we're going to set it equal to 0, because we haven't added anything to it yet. And let's say sum plus equals array at I. Okay, so afterward, let's print out sum. Okay, so we have an error. Sum cannot be resolved to a variable. Sum cannot be resolved to a variable. And that's because of scope. If we look at where we declared sum, notice it's inside these curly brackets. Again, that's a more local scope. So this is its own scope. This is a casino inside Vegas, or however you want to call it that, right? So once we leave the casino, right, sum doesn't exist anymore. Once we leave these curly brackets, sum disappears. It only exists within these blue lines. So if I did want to print out the sum, I would have to put it right here. Just like that. Now, the student of you might also notice where we've declared sum is not good practice, right? Well, why? Let's run it and find out. Okay, so we printed out 5, then 3, then 78, then 34, then 10. Okay, what's going on? That's just the numbers in our array. It didn't add them together. All it did was just print them out individually. As it should, because we said at the beginning of each iteration, sum equals 0, and then we add whatever number we're on to sum. So 0 plus 5 is 5, we print out 5. Then we set sum back to 0. 0 plus 3 is 3, print out the number 3. And that's how we're getting all of these values. So what we actually should do is declare this sum before our loop. Because think about this. When you're counting numbers, do you start over every single time or when you count objects, do you start over every single time you get to a new object? No. You start at 0 before you start counting. So what we're going to do is we're going to start at 0 before we start counting. So let's make some comments to make this very clear. We create a list of numbers. We start at 0. And then we start adding the numbers together. Right, that's what's happening on each of these lines, which is why we want to create this variable before the for loop starts. So now, this line still works because sum exists within the scope of this variable, right? So this variable exists from here to here. So anywhere inside this blue, we can reference this variable called sum, which is what we're doing here. So we add array at I to sum, and then let's say we don't necessarily want to print out sum every single time we add a new number. Let's only print it out at the end. So when this for loop ends, we are done adding, right? Because the for loop's main function right now is just to add our numbers together. Or I should say, everything inside our for loop. The function is to add things together. So here we display the result, which is sum. Now if we run that, our sum is 130. So now it works how we wanted it to from the beginning. So again, anytime you see these curly brackets, immediately start thinking about scope. So whether that's a for loop or an if statement, if sum is greater than 100, we have these curly brackets, right? So that denotes there's a change of scope. Then we're going to sys out, yay. And then if we create a variable, or let's have it be a Boolean over 100, and we're going to set it to true. Then down here, if we say, oops, let me move this comment. If you go down here and say if over 100, again, that doesn't work because over 100 cannot be resolved to a variable because over 100 only exists within this scope. So we would have to declare this over 100 variable outside of this scope so that we can reference it inside the scope, but it still exists outside and we can use it afterward. So we could say Boolean over 100, and then we can say equals false because we're going to initialize it or else it'll scream at us. And then over 100 will equal true, and now this won't give us an error anymore. Furthermore, with if statements, you might not have those curly brackets, right? Because if there's just one line, let's say we get rid of this Boolean nonsense. If all we're doing is printing out this message, we don't necessarily need these curly brackets. So let's get rid of those, right? And now, if we reformat our code, it still has this indent right here. So this is still technically a change of scope, but it's not as clear because there's no curly brackets. So even though we don't have the curly brackets, we are invoking a change of scope, and you can denote that by this indent right here. And as a matter of fact, if we try to change this line to declare a variable, int x equals 10, it actually doesn't let you because there's no sense in creating a variable here because the way that we set up our if statement, there's only one line that exists inside this scope. And on that one line, if all we do is declare a variable, on the next line it'll immediately disappear without ever being used. So there's really no point to doing this. If we instead change it back to sysout, yay, then it lets us do that because we're not declaring a variable, we're running some method because this is in fact a method. If you watch my methods video, it does follow the same format. You have some sort of command. I will talk about the dot operator very soon. But essentially, the way that we can recognize that this is a method is because we have some command and then followed by parentheses. And then inside here would be our argument. So that's just sort of a fun fact, I guess. So I think that's going to do it for today's video. Hopefully this was insightful. I know scoping can be one of the more confusing parts to learning Java or learning a programming language for the first time. So If you are at all confused, feel free to leave a comment below, and I will try to clear up as much confusion as I possibly can.